So now we're going to start assembling the power board. These are the things that you will need for it. 2 GBTs, you will need some L caps, you will also need this film caps here to put on it. You will need a 100 ohm resistor or 90 to 100 ohm resistor, the current sensor, 2 10 kilo ohm resistors here, and 1 10 nanofarad capacitor. So let's start putting these things in. Okay. The way we do it is just put one part in and bend the legs so that they bend the leads so that they don't get out. And you stick all the parts and then turn over and solder. This should be pretty consistent with our instructions on the website. Okay. 100 ohm goes here. Okay. Then the current sensor goes into these holes, and you might need to bend the legs a little bit so that it actually fits into the holes here. Okay. So now it's good. Then we turn over and solder this parts of the components. So these are now soldered together to the board, and we also put in this 3-pin connector. The reason sequence matters a little bit here is because if you put all the capacitors and all the big parts on here, you will not be able to hold these parts when you turn it over. So it actually makes it quite a bit easier to follow the sequence. So the next one, we are going to place some film capacitors. Again, the reason we put film capacitors first is because they're shorter than these guys, the L caps. So just put them in to the board in various places. There are 3 places here where they go. They generally fit right in. Now we do here, we bend the legs a little bit so they stay put. What we use here for these jobs is this little guy. This is a 400 watt soldering gun. So really powerful. Okay, wait 30 seconds for it to heat up, and then we'll solder the rest. The next thing that we will do while we're waiting for it to heat up, we will put in the L caps on the board. Now when you put L caps on the boards, the most important thing is not to mess up the polarity. And sounds obvious, but you would be surprised how many times we, in our lab, messed it up and blew up the capacitors. This is actually pretty spectacular. If you want a firework and great display, you could try that. At a 240 volts rectified applied in reverse to these capacitors is pretty interesting. So the square pads here are the positive pads. The next one over is negative, so that's how you put it in. If this is a negative strip, you put it to the negative. So make sure that everything aligns. We made it easier for you in the newest revision of the kit, that all the positive pads are on one side, generally, except for these guy here. Everywhere else, they are all on one side. So if you look at the board once it's completed and not all the caps look in the same way, then you might have a problem. Okay, so now this is pretty hot. You can go ahead and solder the film caps. Oh, nice! It's going much better. Much better. The only thing you have to be careful with this kind of soldering gun is to not overheat and melt the parts. That actually happened to us as well before. Okay, so film caps are done. Next is electrolytic caps. Okay, so we put all these caps in. Now we're ready to solder. Again, check the orientation. All the minus strips look the same way, except for this guy, which looks up, same way. Okay, turn it over and solder. Pressing it like this so everything is in, and then start putting some solder on it. Again, heating up this. This is you pretty much have to have at least 100-watt iron to do this part because of these large copper areas that are there to carry the currents, the 12 kilowatts of power that you're about to enjoy. But the flip side is that it's kind of difficult to solder. All right, but this guy will help. Okay, let's see if it's hot enough. Okay, it's getting there. So really, no rocket science to how you do this. The important piece is to keep your gun at the connection for a bit, like a few seconds, to make sure that it heats up properly and all the way through. Otherwise, your solder joint is not gonna hold, and it also might not be able to carry all the currents that you need it to carry. Okay, hold on quite nicely. Alright. Okay, these joints are all complete now. Took a few minutes even with this kind of gun. So the next thing you do is just clean off any solder remainings that you might have on the board here from the soldering job that you just did, so that they don't short anything later. Okay, just clean it off a little bit. Yeah, there are a bunch of things that I need to clean off here. Okay, so we're good now. Alright, next thing that you want to do is to put some wire connections on it. So there's going to be a few sensor pickup points on this board that you want to attach now before you put this board onto the GBTs, because after that it will be super tough to do. So what we do here, there's going to be a total of 5 wires. We use different colors to make it easier on us. So we use red color to pick up the PFC voltage. We use yellow color to pick up the input voltage right here. We use blue and black to pick off the current signal of this resistor and capacitor here, and we use white to pick off the output voltage from this pad here. And generally there are pads specifically for wires that are pre-placed in all those areas. Okay. One more thing that we have to do here is to put this resistor. That is a safety resistor. If you power the charger off, it will help dissipate all the charge from these capacitors in a few minutes. It's really not critical what value you use. We might supply 200 kiloohms in your kit, or we might supply 82 kiloohms or 50 kiloohms. It doesn't really matter. It just has to be there. Okay, so we're going to put this resistor in for, next, and then some wiring here. Okay, this is how it will look when the wires are placed. Red, white, black, blue, and yellow. So we're now going to turn over and solder. Okay, so these are all soldered together. Now you notice that we twisted these wires, the blue and black twisted together. This is actually a pretty sensitive pickup line. It picks up the current from the board, and these are really, tens of millivolts that matter here. So really sensitive line. You want to twist it tightly before it enters the driver board. And these are just voltage pickups, so they're a little bit less sensitive, but we still twist them together. So next thing you do is, using this pins, you would prepare the connector for the driver board. So you just take off a pin here, put it on one of the ends of the stripped wire, and then you can crimp it together like this. And on the other side. And then for best connection, just put some solder and make sure that it goes in and penetrates. Okay, done. So you do this for all 5, and then we're going to put those ends into this connector. Okay, so put the ends, or crimped the pins and soldered the pins to all of these. Now what we want to do is to put them in the right sequence into this header here. So what could be useful is if you look at the driver board, and this is how the connector will be placed. All right, with the tab, with the locking tab on the bottom of the board, or facing the bottom of the board. So if we do that, then we could see how we should actually connect, put the wires in. Right, so look at the right orientation. So the connector will go like this. You read the labelings on the driver board. So the first one over is says VOVP. This is over voltage protection. This is the PFC output voltage. And this is our red wire here. So red wire goes to the first position. Like that. It will click and it will lock. The next wire over is VBOP. This is brownout protection. This is the input voltage pickup. This is the yellow wire. So the next one to go in is a yellow wire. The next one over on the driver board is VOUT. This is the output voltage. This is our white wire. Goes in. The next one over is ISS. This is current signal. S stands for signal. This is the blue wire that is connected to ISS pickup on the board, on the power board. So it's a blue wire coming in. Okay, locks. And the last one is black, labeled ISG, which stands for current signal ground. Okay, so now we have a complete connector built up for the driver board. The driver board will go in to the power board like this later. It will have this connector sitting here, and this connector will just mate to it like that. Like that. And all the connections will be made correctly, and you cannot mix it up because this connector has polarity. Alright, so the next thing we're going to do is we are going to put in the copper piece of copper wire into those holes between these capacitors, or among these capacitors. This will be our connection for the negative, for the high voltage ground. In the previous versions, we actually used the 3 milliohm resistors for that, but then we've measured some resistances on the PCB itself and found out that we don't actually need to use those resistors anymore. The PCB from this point to the point of entry of the current on a GBT actually has finite resistance, and that's sufficient for picking up the overcurrent signal by the PFC chip. At 100 amps peak current from 240 volt outlet, even small resistance that we have here is sufficient to generate significant voltage. Just tells you one more time how significant the currents are that this design can provide. Okay, so we're going to do that next, and then we are going to mount IGBTs. Here's what we do to make that connection. We take a sufficiently thick piece of bare copper wire. This is, I believe, is gauge 10, and we just put it into these holes from the other side, into these holes. So we need to bend it just so that it fits perfectly. Yep, something like that. And then we put it from the other side. With the pliers, we go in and put it in. Might need to hold it a little bit and push it in a little bit so that it It is fixed in its position. Here it is on the other side, and we again going to use the soldering gun to solder it up. Okay, so that connector is now in between these caps. The next thing to do here is to put in this 6-inch long wires into the boards to pick up the rectified AC voltage. This will be used for a 12-volt adapter pickup later. It's the most easy thing to do is to build that pickup now. So we are going to put one into the hole right here, into this hole right here next to the copper wire that you just put in, and the other one can be soldered to this hole here that has some plating on it. It is actually a mounting hole for the screwdriver to pass through, but we can still solder on the side. So we're going to connect these wires there and there. So the last thing to do, electric connections wise, for the power board is to place IGBT connectors on the board. So here's how you do it. Take an IGBT. On the right side IGBT will have its left side connections be made to the board. So you put this tab connectors that are included in your kit on the left terminals of this guy, and another IGBT you put these tabs onto the right side control terminals. They might read E2, G2 on the left one and G1, E1 on the right one, but you might also get IGBTs that don't have any markings on those connectors. So, but it's not important at this point. They're all conforming to the same convention, and all of them will be compatible with the power board here. Okay, so next you lower down the power board so that these connectors, these pins, go through the terminals, go through the pads here. Okay, so let's try it. Let's try it here, and we'll show how it goes. You might need to bend the legs a little bit. This is not a big deal. Again, different versions of IGBTs might come with different distances between these legs, so you might need to adjust it a little bit. And as you're adjusting, look at how the terminals, the main terminals of IGBT, show up through the pads, through the large pads on the board here. You want to make sure they're as aligned as possible to the board. So you might need to move things around a little bit and bending the connections a little bit more as you try to do this. Then try to seat them up as much as you can. Okay, and then you would solder those connectors to the board, the terminals to the board. Be careful not to fill all the adjacent holes as you solder to the board, because those will be used for the similar connectors on the other side that would go to the driver board. Okay, so these are the connectors that we just built, and they go through, and that's how they interface IGBTs right there. Okay, there's some bending, it's okay, and the holes go right through. So you see these terminals, they go right through and ready to be bolted on. Okay, the last thing we have to do with IGBTs is to short out the unused pins, right? So you used one pair of pins per IGBT, the other pair needs to be shorted. The way you do it is you can now remove the board, or rather remove the IGBTs from the board. Okay, and take the other pin, the other pair of pins, and just bend them towards each other, and then close like that, and then do the same thing here on the other one, the opposite. So these are opposite sides, and now we're just going to apply some solder on it so that the connection is positive. Alright, so these are IGBTs that I talked about that might need some spacers between the board and the IGBT before you mount them together. So let's try to find some spacers. The things that we use here are just this copper washers, and we would just put a couple of them on each of the legs. Try to use copper standoffs, because otherwise, again, the currents here are relatively sizable, and you don't want things to be heating up too much. I'm placing these things roughly at the right distance. You might need to pull the pins back together so that they go into your connectors. Lower it down gradually. Okay, it's going in, it's going in, it's going in. So it's going in nicely. Center the washers under the board, and now we can start screwing things together. So for IGBTs, these are either M5 bolts, or you can use 1032. Actually, they work surprisingly well. You might want to use the lock washer here because of the vibrations that this unit will endure in your car. So the bolts are now in. For at this time, you want to use only 3 bolts, because we are going to use different hardware for the rest of these. Tighten them up reasonably well. Same here. So specifically, we're just going to show you what we did in a second. These are the ones that we placed. On the right, to me, right IGBT, we placed only the bottom bolt. On the left, we placed the bottom 2. The reason is that the other 2 on the right side will be also used for some wire pickup, and the top on the left will be used for the wire pickup as well. So we're gonna put different type of the bolt there. Okay. You can also decide to just screw it in, not super tightly, but just screw it in so that things don't move too much as you move the board around. In fact, this is what we're gonna do now. I'm not using lock washers this time because we are going to disassemble them later. This is just to keep things tidy. Okay. And the last one in the middle on the right side. Okay. Great. So now we have a complete power board, at least up to this level we have it reasonably complete. What we are going to do next is to make sure that there are no potential shorts anywhere. Just look very carefully, because this could be an expensive mistake. So one that I see here is one of the legs of this capacitor is too close to one of the terminals of my GBT here. So I'm going to reach in and try to trim it. If I can't trim it, I will need to remove the IGBT and trim it that way.